Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, everybody? Today, inshallah, we're going to talk about trigonometric identities. This topic, as you see, we're going to work in some fixed equations that we need them on trigonometry. The first one that we're going to start with is sine over cosine is equal to tan. You know that sine is equal to opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is equal to opposite over adjacent. We know these rules before. So katua. This is the rule. So ka twa. Fine. Now how are you going to prove that sine over cosine is equal to tan? As you have a right angle triangle, which means we're supposed to use Pythagoras. Remember Pythagoras. If you have angle theta, this side is at the front of this angle. So this is the opposite, this is the adjacent, and this is the hypotenuse. If the angle is here, now you're going to change these two sides. This side will be the opposite and this side will be the adjacent. Anyway, this angle, so this is opposite, adjacent, hypotenuse. O, A, and H. So sine theta is equal to O over H, which is equal to X over R, opposite over hypotenuse. Cosine is A over H, which is Y over R. Now let's start from the left-hand side of this identity. So this statement, we called it identity. Why we call it identity? What do you mean by the word identity? Identity means two sides are equal to each other. It's not like the equation. And the equation, sometimes you have a missing part, and this missing part could be satisfying the equation or doesn't. But here, the two sides, they're supposed to be equal to each other. So the left side of the identity is sine over cosine, sine over cosine. Sine is X over R, and cosine is Y over R. Now, denominator cancel the denominator because they are the same. Now, only X over Y left, X over Y. Now, if you work on the right-hand side, tan theta is equal to opposite over adjacent, which is X over Y. As you see, both of them are equal to each other, so which means both sides are equal now. Left-hand side is equal to right-hand side. This is how to prove this identity. The second identity is sine squared plus cosine squared is equal to 1. What do you call this identity? We call it Pythagorean identity. How are we going to prove that this identity? Easily, we're going to use Pythagoras rule. This is the right angle triangle. This is the angle theta again. It's exactly as we did before. Opposite, adjacent, and hypotenuse. Using Pythagoras, hypotenuse squared is equal to the sum of the squaring of the other two sides. So r squared equals to x squared plus y squared. Or as we did before, a squared plus b squared is equal to c squared. So a is representing x, b is representing y, and c stand for r, or r stand for c. Now sine theta is equal to x over r, cosine is y over r. It's as we did before, opposite over adjacent, and adjacent opposite over hypotenuse for the sine, and cosine is adjacent over hypotenuse. O over h, a over h. Now let's start from the left-hand side. Left-hand side is sine squared, and the sine, we have it as x over r, so just replace that there. X over r power of 2. And cosine is y over r, which is equal to y over r power of 2. By squaring both numerator and denominator, x squared over r squared plus y squared over r squared. Now the denominator is r squared now. You have a common denominator, so you have to combine what you have in the numerator. X squared plus y squared is equal to r squared from Pythagoras. R squared divided r squared is equal to what? 1. So which is equal to right-hand side. So left-hand side is equal to right-hand side. Very important note. From this Pythagorean identity, you can get two more. You can write sine squared in terms of cosine squared, or cosine squared in terms of sine squared. So sine squared is 1 minus cosine squared, and cosine squared equals to 1 minus sine squared. Third identity as you have now is sine 90 minus theta is equal to cosine theta. And the fourth one is cosine of 90 minus theta is equal to sine theta. Simply, this note is giving you all the idea of these two identities. Any two angles, sum of them is 90 degrees. So sine of one of them is equal to cosine of the other, and cosine of one of them is equal to sine of the other. Any two angles, sum of them is 90, sine of one of the angles is equal to cosine of the other, and cosine of one of them is equal to sine of the other. Simply. For example, sine 30 and cosine 60. 30 plus 60 is equal to what? 90 degrees. So sine of 30 is equal to cosine 60. And cosine 30 is equal to sine 60. Simply. 45 as well. Sine 45 and cosine 45 are equal to each other. Why? And because the sum of the two angles is 90 degrees. This is simply that you have in this paper. Exercise 16C, page 275 in the textbook. Question number 1. S is equal to sine theta and C is equal to cosine theta. Simplifying, square root of 1 minus s squared is equal to square root of 1 minus sine squared. Why? Because s is sine theta, so square root of 1 minus sine squared. 1 minus sine squared from the previous page or the previous paper is equal to cosine squared. Square root of anything squared, they will cancel each other and you have only cosine left. Simply. D, it has the same idea. SC over square root of 1 minus s squared. S is sine, C is cosine, square root of 1 minus s squared. We did that in the previous question, which is equal to cosine. So sine, cosine over cosine. Cosine, cancel cosine. Cosine divided cosine is equal to 1. So only sine theta left. Let's solve this question. C power of 4 minus s power of 4 is equal to c squared minus s squared. What are you supposed to do? We're going to change c into cosine, so it's cosine power of 4 theta minus sine power of 4 theta over cosine squared minus sine squared. Now we're going to deal with the expression in the numerator as a difference of two squares. You remember the rule of difference of two squares. Cosine squared plus sine squared and cosine squared minus sine squared over cosine squared minus sine squared. Cancelled. Now only one expression left in the numerator. Cosine squared plus sine squared is equal to 1. Question 3. Find without using a calculator the values of sine theta, tan theta, if cosine theta is 4 or 5. And remember, theta is acute. I told you before, on all the quadrants, see, on the unit circle, all the angles in the first quadrant, we call them acute angles between 0 to 90. Angles between 90 and 180, we call them obtuse angles. All the angles between 180 and 360, we call them reflex angles. Cosine is A over H, adjacent and hypotenuse. So this is the right angle triangle. This is angle theta. Adjacent is 4, hypotenuse is 5. We're supposed to find the opposite. How are we going to find the opposite? Use Pythagoras. So A is equal to directly this squared minus this squared. Only in one case you have to do plus if the hypotenuse is the unknown part. So you do 5 squared minus 4 squared, which is equal to 3. So the opposite side is 3. Why they giving you the angle? Because that will change or will affect the sign of the ratios. I mean sine, cosine, and tan by the word ratios. In the first quadrant, remember we said A, all the ratios are positive. Sine, cosine, and tan. In the second, we have only S, which is sine, third, tan, fourth, cosine. So all the ratios, all the sine, cosine, tan, all the functions, all the trigonometric functions positive in the first quadrant. So what you're supposed to do now, sine, now we got the opposite, sine theta is opposite over hypotenuse. Opposite is 3, hypotenuse is 5. What about tan theta? Tan theta is opposite over adjacent. So opposite, which is 3, and adjacent is 4. And as you see, both of them taking positive sign. Now let's do the same thing with the question B. Cosine theta, tan theta. If sine theta is 5 over 13, sine is O over H. Now we're supposed to find what? The adjacent. So the adjacent, this is the triangle, right angle triangle, angle theta, 5 and 13. Let's find the, let's call it X, missing side. So square root of 13 squared minus 5 squared, which is equal to 12. So the adjacent side is 12, using Pythagoras. Obtuse means the angle on the second quadrant, which means only the sine ratio will take the positive. So this is the only function will take the positive. What about cosine and tan? What about cosine and tan? They will take negative signs. So cosine theta is equal to A over H. Adjacent is 12, so 12 over 13. But you have to give negative sign. So that negative sign because of the obtuse angle. What about tan theta? Tan theta is opposite over adjacent, and it's negative. Why it's negative? Because of obtuse angle. So what's the ratio? It's opposite over adjacent. Opposite is 5 and adjacent is 12. Okay guys, last question on this idea. The question asks you to find sine and cosine if tan is equal to negative 7 over 24 and theta is reflex. Reflex means the angle lying on the third quadrant or might be in the fourth quadrant. So how are you going to state that? See, these are the quadrants. Reflex might be in the third or fourth. Tan positive here, cosine positive here. All and sine. Good. Now, as you see, tan has negative sign. So tan has negative, not on the third. Third, tan has the positive. But on the fourth, tan has negative because cosine has the positive. So tan theta, that ratio, it has to be in the fourth quadrant. Fine. Now, I want to mention something here. The question asks you to find out without using a calculator. What that means? What does it mean to never use the calculator? Means don't find the angle at all. So because some of the students, they think to take the inverse or to find the unknown angle and then start to find the rest. It's completely right. It's not wrong. But if the question asks you to do that without using calculator, you're supposed to work this. You have to show the working out without finding the angle. But if the question asks you just to find, and they never mention the question without using the calculator, you can use any way that you like. Good. Now, tan is equal to O over A, opposite over adjacent. In the right angle triangle, opposite is 7, adjacent is 24. We have to find the, let's call that side, the missing side is y. Let's find the hypotenuse, square root of. Now, into this case, you have to do plus 7 squared plus 24 squared, then y is equal to 25. Now, sine is equal to opposite over hypotenuse, and sine is supposed to take a negative sign because it's in the fourth quadrant. So negative opposite, which is 7 over 25, and cosine is A over H, but has to take positive. Why? Because we are in the fourth quadrant, and in the fourth quadrant, cosine has positive sign. So positive A adjacent is 24, and hypotenuse is 25. Let's do question number 4. Question number 4, it's required to find values of theta, solving equation. By the way, for these questions starting from 4 to 13, we're going to divide them into 2 videos. We're going to do today, inshallah, from 4 to maybe 6 and 7, and then the next video, inshallah, we'll do the rest of the questions. Find values of theta between 0 and 360. I know in the question they didn't mention at all the range into this case or into this form. They said theta from 0 to 360 inclusive. What the inclusive mean? Inclusive mean these 2 angles are including in the range. Fine. Which satisfy. First one, cosine theta equals to half. Cosine theta equals to half. Based on the quadrants, cosine positive, we have to state first of all the quadrants that we're going to find the angles. 0, 90, 180, 270, and 360. Cosine positive on the first and fourth. What are the expressions? Theta on the first, you have to back to the previous video, theta, and on the fourth, 360 minus theta in the previous topic, trigonometric functions. Now, when we explain the quadrants. Then we're going to find the angle which lying in the first quadrant. What do we call that? We called it reference angle. So theta equals to inverse cosine of 1 over 2 in the calculator is equal to 60 degrees. So this is the reference angle. Now we have 2 angles which giving you cosine theta equals to half. So 60 on the first quadrant and 360 minus theta on the fourth quadrant. So 360 minus 60 is equal to 300. So we got 2 angles, 60 and 300. Tan theta is equal to tan theta is equal to 1. Tan positive on the first and third, theta and 180 plus theta. This is from 0 to 360. First of all, you find the reference angle, theta, equals to inverse tan of 1, which is equal to 45 degrees. So theta on the first is 45 and on the third is 180 plus 45. So the angles are 45 and 225. 2 angles. Cosine negative. So remember, cosine positive on the first and fourth, but it's negative on the second and third. What are the expressions? 180 minus and 180 plus. How are we going to find the reference angle? So please don't ever take the inverse of a negative ratio. You're supposed to use the positive only. So theta equals to inverse cosine of root of 3 over 2. Why I have to say that? In cosine, you will not find a problem. Sometimes you'll find either. But in sine and tan, you'll find the angle but in the negative sign. And whenever using that with the expressions, you'll find an angle which is out of the range. So you have to use only the positive ratio. Inverse cosine of root of 3 over 2 is 30, because sine 30 is equal to half. Cosine 30 is root of 3 over 2. So theta, use them with the expressions 180 minus 30 and 180 plus 30. So we have to get 2 angles, 150 and 210. Now, last one on this question, cosine theta plus 60 is equal to 0.5. So what you're supposed to do first, theta plus 60, you just keep it as it is, and you do inverse cosine of 0.5. Basically, inverse cosine of 0.5. 0.5 is half, which is 60 degrees. Based on the range cosine positive in the first and fourth, expressions are theta and 360 minus theta. So theta plus 60 is equal to 60 on the first and 360 minus 60 on the fourth. Now move 60 to the other side. So you do first 60 minus 60, which is equal to 0. Then 360 minus 60 minus 60 is equal to 240, because 360 minus 60 is 300 and 300 minus 60 is 240. Question number 5. For 0, theta between 0 and 2 pi, solve. Sine theta minus pi over 6 is equal to 1. What you're supposed to do first, we have to find the reference angle. Theta minus pi over 6 is equal to inverse sine of 1, which is equal to, you have to use and change the calculator mode to radian, because this is radian. You know the way of changing the calculator, you just press shift mode and then you press 4. Inverse sine of 1 is equal to pi over 2. It's only one angle. I know sine positive on the first and second, the expressions are theta and pi minus theta. If you do inverse sine of 1, you'll find pi over 2. So whenever you use them in both, you use pi over 2 in both expressions, you'll find exactly the same answer. So it has to be only one angle, because pi over 2 is the 90 degrees angle. So just move negative pi over 6 to the other side. So you do pi over 2 plus pi over 6. So theta is equal to 4 pi over 6, which is 2 pi over 3. Question number 6. Again, you have to solve in radian, but now you have power of 2 here. So you have to take the square root first. And remember, whenever you take the square root, you have to give two values, positive and negative. Sine x is equal to positive and negative half. Why? Because you do sine x equals to root of quarter. Positive and negative root of quarter. And root of quarter is half. So we're supposed to work in all the quadrants. Why? Because sine positive in 2 quadrants and negative in the other 2 quadrants. Sine positive here and negative in 3rd and 4th. Expressions are theta, pi minus theta, pi plus theta. Remember, you just write instead of the pi 180 if you work in degrees, and 2 pi minus theta. So first of all, you find the reference angle. Inverse sine of half, which is equal to pi over 6. Now we're supposed to find for sine x equals to positive half and for the sine x equals to negative half. Here we're going to use only the first 2 quadrants because sine positive in these 2 quadrants. So x equals to sine inverse sine of half, which is equal to pi over 6. Then x is equal to pi over 6 and pi minus pi over 6, which is equal to 5 pi over 6. So these 2 angles. If you do exactly the same thing with sine x is equal to negative half, so you know the reference angle is still pi over 6, but you have to use them in the 3rd and 4th. So x is equal to pi plus pi over 6 and 2 pi minus pi over 6. So x is equal to 7 pi over 6 and 11 pi over 6. Question number 6D. Tan 2x is equal to negative 1. Now the range is from 0 to 2 pi. You have 2x, you have a multiple with the angle. Whenever you have a multiple with the angle, you have to change the range by multiplying the whole range by 2. Whenever you have 3, multiply by 3, multiplying half if you have half. So multiplying the whole range by half, and so on. Now we have to find the reference angle. The reference angle is pi over 4. Inverse tan of 1 is pi over 4. Don't use ever the negative sign. Then the range which is given to you is from 0 to 2 pi. 0, pi over 2, pi, 3 pi over 2, and 2 pi. This is the first term. 4 pi means you're supposed to use the second term. So second term, you have to add 2 pi or 360 in case of degrees to each quadrant. So theta plus 2 pi in the first quadrant, pi minus theta plus 2 pi, and so on. We know that tan positive, negative on the second and fourth. It's positive in the first and third. So we're supposed to use only these two quadrants. Pi minus pi over 4, because this is the reference angle, and then pi minus pi over 4 plus 2 pi. Then on the fourth quadrant, 2 pi minus pi over 4, and 2 pi minus pi over 4 plus 2 pi. We got the angles by the calculation, and then you divide all the angles by 2, you just change the denominator to 8. Question number 7, based on the range which is given to you is from negative 180 to positive 180, which means we have two quadrants from the positive and two quadrants from the negative. From the positive, two quadrants, and from the negative, two quadrants. See, 0, 90, 180, 270, 360, negative range 0, negative 90, negative 180, negative 270, and negative 360. Now it's required to work only in the first two quadrants from the positive, from 0 to 180, and the last two quadrants on the negative range. But the point is we have 2 theta, which means we have to multiply and change the range. Now the new range is from negative 360 to positive 360. Cosine, as you see, what is the sign of cosine? It's positive here, right? So cosine to theta equals to quarter. Cosine positive on the first and fourth. Expressions are theta, 360 minus theta, here negative theta, and theta minus 360. You have to back to the previous video. You'll find all the range are there. Fine. Inverse cosine. So using the calculator, inverse cosine of quarter. But remember, you have to do that in radian. So the answer is 1.318. 2 theta to find the reference angle equals to inverse cosine of quarter, which is equal to 1.318, which is approximately 1.32, correct to 2 decimal places. Then you have to use the range. I know the range which is given to you is in degrees, so let's use that. We have to change the calculator now. This is in radian, but in degrees. You just change the calculator mode, shift mode to degrees, and then you calculate that. Then the answer is 75.5 in degrees. 75.5. So 2 theta equals 75.5. 360 minus 75.5. 75.5 minus 360, and negative 75.5. Then 2 theta equals 75.5, positive and negative. These two angles are the same, but they're having different signs. And even these two expressions will give you exactly the same answer. So 360 minus 75.5 is equal to 284. So positive and negative, 284.5. Now you're supposed to divide both sides by 2. So 75.5 divided by 2 is equal to 37.75 degrees, positive and negative. Then 284.5 dividing by 2 is equal to 142.25. Now we got the answers as 4 angles.